in the Cribl community Slack, and I will be happy to share or answer any questions you might have about the events and what we have in the hopper for what we've been calling hot summer events. All right. I think that's all I had. Brendan, you ready? Stretched?
I am ready. Let's do this.
All right. Then the floor screen is yours.
All right. So we are talking about REST APIs today, and specifically how to hook up REST APIs into Cribl Stream and get data out of them. So what we're talking about today, let's give a little bit overview. What is HTTP, Hypertext Transfer Protocol? We'll go through that real quick because that's going to be very important when we start talking about how to configure things. So we'll talk about discovery, collection, how all that ties together inside Cribl Stream. Go through a few advanced settings like authentication, pagination, event breaking, so on and so forth. All the good stuff to get your data into the right format before it gets forwarded to the destinations. And then we'll talk about scheduling collection jobs. I love this meme on the right here. Anytime somebody in our internal Slack says API or REST, I'm like, oh, hello, let me help you. So this kind of a condensed version of what those discussions are usually about. So what is an HTTP request? So with the Cribl Stream collector here for REST APIs, we're making HTTP requests out to servers in order to gather data and return that back as events. In order to do that, we have to send this request, and this is done using HTTP. So there's a very well-structured format for HTTP. Typically, you're using a method like get or post. Less commonly, there's other methods like put, patch, delete. Those are for kind of updating specific REST API endpoints if you wanted to perform an action. But typically, we see get and post as the two methods that are used. You have an endpoint involved. In this case, it could be something like API v1 health, or it could be something very complex that you're adding parameters, query string, headers, whatever that needs to be. Along with that, headers like authorization, so sending bearer tokens or login credentials, setting things like cache control, keep alive, so on and so forth. So if you've never seen what HTTP request looks like before, on the right side of the page here, this is actually a request out to cribl.io to get the home page. This was used with the curl command, so curl https cribl.io. You can see at the top here, the curl command sent a few headers. Here's our get, so our method. Here's our endpoint, which is slash, and I'm using the HTTP 2.0 protocol. You can see I've also sent some other headers like the host name, the user agent, in this case it was curl, and I'm accepting any type of response back. So those were automatically set for me. I didn't have to think about it. Down below, we're seeing the response back. So I'm getting some information back from the Cribl server, what type of content this is, how long the content is, the server type that took this request and responded to it. And here's the actual HTML at the bottom that was returned as part of the payload. So really, this is the data that we're interested in here for our REST APIs. So that's what we'll start collecting on the next slide here. So this is the screenshot of the REST API collector configuration page without anything set. So there are a couple sections here I do want to call out. So at the top of this, you can see we've got a collector ID. We also have an accordion here that opens. You can enter some discovery information. That's typically used to dynamically configure what we should be collecting. You could set, let's say you needed to collect from 3 different endpoints and you wanted to do that in one collection job. You could add 3 different discovery items and then enter that into the collection URL here using a parameter. I'll show that in a little bit. You've got some additional settings here, method, parameters, headers. I want to call it too pagination. So in the REST API world, a lot of the endpoints are paginated, which means it returns a chunk of results back and gives some indication whether that's a pointer to the next page or that's the number of items in total, and the offset or limit of the number of items that have been returned. So depending on your use case, you can customize the pagination that's used to make sure you collect all the data and not just the first page. There's some other settings too, like authentication, if you need to log in and obtain a bearer token or pass some credentials, like basic authentication, that can be done here. We'll also talk about the event breakers here. Very handy when it comes to JSON data being returned in an array format. So this can be difficult to work with, especially when you want that array to be individual events. So using a custom event breaker would allow you to actually unroll those events before they even make it to your routes and pipelines inside Cribl Stream. So how does collection actually work when it comes to running a collection job? So on the previous screen, this would be configuring a job. So I'm going to configure a collection job to go do something. A job is made up of individual tasks, and they're actually done in this order here. So if I need to authenticate to the endpoint, we'll go do that as the first item, obtain the bearer token or send the credentials. That authentication information is sent. If I need to do discovery of the data, let's say I'm going out to an API endpoint to discover which type of data I need to collect, we'll send that authentication there. We get the result back from the discovery, and the discovery then goes and runs collection tasks. So basically, discovery is seeding the number of collection tasks that need to be run. So depending on the number of results, that will trigger the number of collection tasks that need to go be run. From there, event breaking is performed on the response of that data, and then any final filtering of that data. So I was told there would be jobs. There's lots of jobs, really tasks that are run as part of this. And so if you were to run a collection job and look at the inspector, you'll actually see there's a number of tasks that are run as part of this. And this is what makes up those tasks. So configuring discovery, there's a couple different discovery options here. There's none, which really is a bit of a misnomer, because if I set my discovery to none, it's actually implicitly returning one item to the collector. And that's in order to seed the collection job. If I returned no discovery items, it would actually not collect anything. So if you want a little homework experiment, go try this with the scripted collector. In the scripted collector, don't enter any commands in the discovery section. Just enter a command in the collection section. You'll see it actually never runs the collection job. But then go back and configure something like echo, foo equals bar in your discovery phase, and you'll notice that the collector then runs. So a little trivia there. On the next item here, so static discovery, that would be your JSON response or item list. So you can customize, basically, if you have a known set of items that you need to collect, whether that's endpoints, objects, something like that, you can customize that and enter that information here. The last is a dynamic discovery. So making an HTTP request to an endpoint, obtaining the objects or an array that you need to collect from. So that feeds downstream into collection. So like discovery, there's some options here I like to call out. Obviously, most important, the collect URL, and that URL is used to go and get the data from the endpoint. Now, in this case here, I've just configured a static example. This is a JavaScript enabled field, as you can tell by the blue bar on the left side of the screen. So I can do things like template interpolation of the data. I can use backticks and the $, curly braces, that syntax in order to populate this URL with variables. And you'll see that in a little bit here when I populate the discovery into collection tasks. You can then customize the parameters, collect headers. So you can see this case here, I'm actually doing this in an interesting way. I'm using the internal c.secret function, the log stream expressions, or Cribl stream expressions, I should say, to obtain a text secret and then get the value of that secret, which then becomes the bearer token authorization header. So I can do this like this. I can customize it and use the authentication. This is not one way is the only way to configure your collection and discovery tasks here. Then obviously pagination. So parameters, if you're entering a parameter here, we're talking about specifically parameters in the header section. This looks exactly the same. So with that, again, JavaScript enabled, you can use the C functions to access things like environment variables, secrets, other data. One thing I want to call out too is the use of the earliest and latest variables. So if you've run a file system collector or something like that, maybe even S3 object store collector, you can use earliest and latest in your query parameters or headers in order to customize the data that's returned from the endpoint. And these are set when you run the collection job, whether that is scheduled or ad hoc. So for instance, if you were to use, I'll go over here, kind of explain this. Actually, let's go ahead and populate this. I'll show what this looks like. So I'm going to collect from this endpoint here. We'll call this the goat parade. I'm going to save this and run it. Now, the earliest and latest is actually populated based on entry inside this text box here. So if I were to leave this blank, earliest and latest is undefined. So those variables are not set. Only when I define these are they actually set. So if I were to say 7 days ago, it would populate a variable called earliest with a Unix epoch timestamp of 7 days ago from the current time when I click run, and that would be accessible inside headers or the query string parameters. So I'm not going to set that. In this case, I can run it and we get back. Here's our little Go Parade return from the REST endpoint. So pagination, I'm just going to talk a little bit on this here. There's a couple ways to handle this. Let's say you have an explicit URL that's returned from a specific system. That's these options here. So let's say the URL is returned in the body of the payload. I can use that. Just define the actual path to the specific attribute there. If it's returned as a response header, let's say a header is set, not in the actual body, but in the header, could use that value too. And there's another option here called RFC 5988 or web linking, which is similar to header responses, but it defines a well-formatted URL. And it also defines relationships, self, previous, next, which Cribl Stream can use to automatically paginate based on those results there. Now, there's two other settings here, offset and limit, or page and size, which are similar to each other, but slightly different. These are dynamically calculated or created. We don't actually have a predefined URL like you would have inside these other responses here. What we do is we determine the size of the actual result based on a field value, and then we can dynamically calculate an offset and limit. So basically start at 0 or 1, depending on if it's 0 indexed, collect a limit, maybe that's 25 items or 50 items, adjust your offset. Now I'm starting at item number 26 to collect from, or 25 if it's 0 indexed. Same thing with page. Maybe I start on page 0, then I collect page 1, page 2, and I set my size. Maybe it's 25 or something like that. And I collect until there are no more pages to be returned based on the total number of results that's defined inside that data. I will admit that this just, it doesn't work for all scenarios. Unfortunately, there are many, many, many ways to paginate. We've tried to capture the most common here inside the REST collector. So it may not work for your specific scenario. If it doesn't, let us know. Happy to take feedback in our community. Let's move on to authentication. So in this case here, I've got a screenshot logging in, and this is actually the defaults for the login information here. And this is actually going to Cribl Stream to actually pull data out of the REST API endpoint for Cribl Stream. There's just a little fact there. You could also do basic authentication if you wanted to grab data using username and password that's statically defined. The header gets set, it's base 64 encoded with the username and password concatenated together with a colon in between the two. Well-defined format there. You could also pull data out of the secret store inside Cribl Stream. So if you wanted to do that there, you could also define usernames and passwords inside that secret store and reuse those across the product. Now with login, what will happen is I will go out to this endpoint here. I will submit this post body. This is some JSON data here. The username and password are going to be populated in these two fields, and you can see that string interpolation syntax there, backticks, $signs, curly braces, etc. I am telling Cribl Stream, here's the token that's going to be returned. In this case, it's in a field called token, and then that gets set inside this authorize expression here, and that is passed to the discovery and the collection endpoints, and that's done automatically for you.
Hey, Brendan, one thing I was going to say is if anybody has questions, please go ahead and put them in the chat or chime in. Happy to take some questions as well.
Yeah, absolutely. Cool. So with that, let's move on to event breaking here. This, like I mentioned earlier, very useful for JSON arrays. You can see that this is just a screenshot of the event breaker configuration window. By default, there is a JSON array event breaker type. So there's nothing that needs to be done other than choosing JSON array. And if the data is inside an object and there's an array inside that object, you put in the field name to do that. What this will do is actually unroll the data for you automatically. So let's say there are 5 items in your array. What we'll do is we'll take those 5 items, which looks like one event in the preview. We'll break those into individual items. So now you have 5 events individually broken out. There's some additional settings that you can do here, like if you wanted to automatically extract the JSON from the raw data into structured fields. Say you wanted those as index time fields in Splunk, you could do that. So very useful. You apply this to your event breaker and pretty simple to set up. Filtering. So filtering here, this is one of the most important things other than actually scheduling a job to get set up. The reason is 2 items. We talked about this earlier, the earliest and latest. So when I run a job, what I want to do is collect from a certain time window. Let's say you schedule a job, you want to make sure that you're collecting for that specific time window. Because remember, Cribl today, as of this discussion, is stateless. We do not keep state between runs of these collection jobs. So I have to define a time window, and my REST API needs to also support collection based on a specific time window. Now, what I could do here too is add this into a filter or add some, other parameters into this filter. So this filter allows me to also, on top of the time range, only forward certain events that match my criteria to the destination or destinations that I have configured. So you can basically do time range filtering and then stack on top of that actual event data filtering. So whether that's matching certain conditions, whether that's matching field values, randomly picking events, doesn't matter. Again, JavaScript enabled here. Just evaluate this to true or false, and we'll forward those events. Now, on the same vein here, for considerations for scheduling collection jobs here, this is what I typically recommend for folks that I work with in terms of reliable collection jobs. Setting this to run on a scheduled basis, we want to do is make sure these 2 items match. So let's say I am running this on a 5-minute interval. I want to make sure that I get a 5-minute slice of the world. Otherwise, I'm going to have duplicate data that's returned from my endpoint that's forwarded to the destinations. So once that's configured, I then also want to configure a few other items. Make sure that max concurrent runs is set to 1. Skippable is set to no. And resume misruns is set to yes. Now let me explain why. This is very, very important. Inside Stream, there are limits on the number of jobs that can be run at any given time. That is usually set by default to 10 across your worker group. You can increase that if you want, if you have more worker processes or workers in your group. And I would recommend tuning those limits based on your hardware. Now, what happens here is, let's say you have a lot of scheduled jobs that need to run, and you reach the limit of number of concurrent jobs that you can run. If this is set to yes, Cribl will not run this job. It'll just skip it. So that becomes very problematic, let's say, with reliable delivery of that data to your destination. The reason I set resume misruns is the leader will then reschedule that job to run at a later date. What I want to call out too is, based on the earliest and latest time parameters, you notice that I am actually adding in a what we call snap to time boundary modifier. This is similar to kind of that Splunk syntax where you can do earliest and latest. But basically what this does is, let's say your job runs at 3 seconds after the minute. If I didn't specify -5M at M, I could have a job that runs like this, earliest and latest. Now, let's say my previous job was set to run and it ran at 00, actually at minute hand, second hand at the top of the clock. So I could have had a situation where there's actually that should be, that's wrong. 0, 0, 0, 5, 0, 0. There's actually a condition here where, depending on how these jobs get scheduled, we could be missing data for a few seconds. And this is why it's very important to always have a clean delimiter between earliest and latest. And that's why I recommend having this snap to time boundary, making sure that your jobs are set to run with these time parameters. Now, let's say job gets skipped. We're going to go back. We'll rerun this based on the earliest and latest. We will collect those slices that we missed and get that data forwarded to the destination. Might take a little bit longer than expected, but that data will make it there in a reliable fashion. Pause for a second here. Good stuff. Any questions on this? I mean, this is a lot of data at a high level on REST collection here. And a lot of this actually applies to the other types of collectors, S3, Azure Blob, Google Cloud, file system, etc. A lot of these concepts are still applicable. Maybe some of the considerations for, REST API, slightly different, but all good stuff.
Nothing in the chat so far.
Cool. Let's take a look over here. I'll actually give you kind of a preview of a new sandbox that I'm working on for REST API collection. So this will go through a lot of the different scenarios here. I've built a sample REST API server that works with pagination, things like that. So in this case here, we've already collected our little Go parade. So just making sure that this works. And if you were to run this command down here, you would see we'd get that same result back in the terminal here. So we can test it with curl, and then we can go run it inside Cribl Stream. So let's say discovery, for instance. Now, what I didn't talk about here is actually using some of this string interpolation for getting the data out of the response from the discovery here. So let's take, for instance, maybe I've got an array of JSON data. I'm just going to statically define this here, JSON response. I've got my items. I'm going to call this discover JSON array. And then I'm going to use this. So you can see here what's actually happening. And I have to make one more adjustment. Items. So what I've told Cribl here is use the items field inside this JSON array. And inside this array is the actual items that we need to go collect from. Now you can see each of these objects inside the array has a parameter called ID. And this maps here to this. So we would end up running 3 collection jobs. So we would have 1 discovery job, which returns a result. And then from that, we seed 3 collection jobs based on these parameters here. That ID, the value is passed into here, and that's returned back. So if I were to, for instance, go and run this curl HTTP server collect object, and in this case, I'm going to pass in ID of 1. You can see we get back item number 1. If I run this for object 2, we get item 2 back, and if we run this for 3, we get item 3 back. So this is what I'm expecting to come back based on this discovery here. So I'm going to save and run this, and you can see that's exactly what happened. I got this data back from the collection endpoint. Now, you'll notice inside this, we have 1, 2, 3 in order. Now, that may not happen inside your environment. Let's say you have multiple discovery items. These could run out of sequence. So depending on the parameters that are passed, we could actually have, let's say like 3, 1, 2 in this. So we still collected the data, just may not be in sequence. So keep that in mind as you're running these jobs here. We could do the same exact thing with pulling data from a endpoint. So for instance, if I were to go out and run this here, I can see I get a very similar result back. And then I could actually break this up and feed that into the collection here. So in this case, go out here, server object ID. And when I run this, I'll get my 3 results back here. And you can see when we actually ran this discovery, we've added a new source field in here so I can see where this data came from. It's a nice little tidbit there. Pagination's fun. There's many, many different scenarios that we could run through here in terms of getting this data configured correctly. I'll save you, some of the time, go through the sandbox yourself. But I do want to call out things like the web linking. So for instance, like we talked about, if I were to run this here, you can see the response that comes back. If I can actually drag this terminal, make it bigger. No, apparently I can't. So you can see there's actually 2 links that are returned with a relationship of self. So I called /linking. That was the URL that we had here. And then we can see our next link. So /linking size is 25. We put some defaults in this here. So if I were to format this out, let's do this. Yes, I'll pass this to JQ. So here we go. We've got some of this data that came back. We can see our items. This would be what is collected. And we've got some information about pagination, the size of the data that was collected. The offset, we're at item number 0. We have 25 total items here. So if I were to do this here and now pass this, let's say offset is 5. When I run this again, we can see that the new self has been updated. We have a previous and we have a next. Now, if I now run this through JQ again, you'll see we have item 6 through 10 instead of 1 through 5 that's been collected. So I can set this to run over and over and over. So in this case here, I can populate this. Linking, I can choose pagination. In this case, I don't really care, but we can add self. I've got the next page name, so I can run this. And you'll see this actually goes and pulls the data. Now, this is slightly problematic because we have our items, we have individual events here in an array. I have 25 items, but I have 5 events. So we need to deal with this. And the way that we deal with this is actually through event breaking. So in this case here, I can configure a custom event breaker that's under knowledge. Go to event breaker rules. I can add a new event breaker here. Let's call this JSON array. And then for rules, let's call it JSON array again. In this case here, I can now choose JSON array as an event breaking type. And if I actually have this, I'm going to copy this value here. So you can see what's happening on the right side in this preview. We're getting the blue as the value, red is our event breaking here. So we've automatically defined the regexes and things like that. So if I were to look at this, let me actually change this regex. You can see the color coding's changed. This will be one event as it comes out. But I choose array. Here we go. We got each individual object as an event of itself. So this is what I want to apply to this, but I need to make one customization to this. The data that is returned in our event, or result, I should say, response, it's actually in a field called items. So if I change this a little bit, items, it's actually automatically figured it out, but you can define this. If I define items here as the array field, we're going to actually pull this. Now, if I had multiple arrays, this would be very important. But in this case, I'm just going to go ahead and define it. We'll call it good. Yes, continue and save. So let's go back to our collectors here. And when I configure this, all I need to do is go to event breakers on the left. I'm going to add a rule set. And I'm going to add our JSON array that was just created here. Now, what I'll note is the system default rule is always here as an event breaker. It is the fallback event breaker. You may see references to that in your events as they're moving through Cribl. That's what the system default rule is. It's actually just looking for new lines, and that is the event breaker that's used. So that's there by default. You can stack as many custom event breaking rule sets on top of this as you want. And that's why the filters are so important inside your event breaking, because you have multiple event breakers, but not all of them apply to your data. In this case here, it will apply to all the data. So we just use true as that filter. So let me save this, and I'm going to run this again, and the results are going to be strikingly different. So instead of having this data be in the array, we now have each of these items as individual events. There's some really cool stuff about this too. So if I show internal fields and I look inside the collectible field here, I can see information about the page number. What was the page number that was used? What was the ID of the task? In this case here, task ID was discovery. I can see some of that information here about the specific job that was run. So I've got some information too on the input ID. If I were to scroll down to event number 6 here, we can see this is now page number 2. Here is the link that was used when it was calculated. And then this is the URL that was actually used to collect from the next page. And if we were to continue to scroll down this, we would see some additional changes of this here. So lots of data. It's a little bit hidden, but you can get to it and see what's going on inside your environment. There is also other ways to find data about the REST API collection jobs. If I were to expand advanced settings here, by default, the log level is set to informational. Now, I could get some additional information about what this task is doing by running it in debug mode. I click run, it looks exactly the same. But when I go to look at the logs here, you'll notice there is a lot of debug level informational items that are returned as part of this. Now, this is important when you're doing some troubleshooting, because I can look for the actual, in this case here, something like sending HTTP requests. You can see there's 5 of these. What is the URL that's being used? And this is very important for things like custom parameters inside the URL. So I can see here, based on the linking, offset 5, offset 10, offset 15, offset 20. So basically we just followed that offset to collect all of these pages. Now, let's say something goes wrong. For instance, it doesn't actually exist. And I run this, in this case, it's returned back not found, because that was that, but we can see there is an error here. And if I were to look at these logs, I could then look at the, let's say, task execution failure, What is the reason that this task did not complete successfully? In this case, it was status code 404 that was not found. This is also included in the task errors tab here, which is only shown if there are errors for collecting this data. So we can see that here. And you might get multiples of these. Some of these are job level, not task level. Remember each task running here. So you might get this back. All right. Good stuff. All right. So that's the end of my brain dump here on REST APIs. Would love any questions. If you can't think of them now, feel free to hop over to our Slack community, hit me up on there, post in general channel, whatever. More than happy to help get your REST API collection working. If there's a feature that is not in the REST API that you would love to hear feedback on that too in our Slack community, so we can pass that to the product managers that help build out this functionality.
Thanks, Brendan. That was great. That was a lot of great information. We have it recorded here. I don't have any questions in the chat. Anybody want to come off mute or any questions? We'll give it just a minute here.
I'll say too is stay tuned. This what you're seeing here is an active development, getting close here. So we'll have a new REST API sandbox available hopefully in the next couple of weeks here once we get it all reviewed.
I was checking that out. That's awesome. All right, I'm going to go ahead and stop the recording, and thank you very much.
Recording stopped.
Thanks, Brady. Have a great rest of your day.
Thanks, everyone.